So the derivative of an antiderivative. Second fundamental theorem of calculus, okay? And honestly, you don't have to really know that it's a second fundamental theorem of calculus, but you really need to know what to do, okay? If I have a derivative of an antiderivative, it's the derivative of the limit, okay, times what? Times plug in the limit, okay? That's what it is. It's the derivative of the limit times plug in the limit. And then what we forget a lot of times is what comes next. It's a minus sign, okay? So it's a derivative of the limit times plug in the limit minus, okay? Then again, it's the derivative of the limit, but what's the derivative of pi over 2? Or anything that's a number? 0. So this just becomes 0, and so that is your answer, okay? If you look on your formula sheet, what you have is kind of one example where you have, I think it's like k to x, I don't know what k, maybe it's a to x down here. And this is a little bit different because it's the derivative, and this would be a t. Okay, so let me get this right. Okay, on your formula sheet, you have something like this. And it just says that this is equal to f of x. Okay, but why? How is this different from this? Instead of x squared, you have an x, right? So the derivative of x is really 1. Okay, so this is 1 times plug in your limit, f of x, right, minus 0. And that's why your formula sheet looks like this. Okay, but I really don't memorize this. I just know the formula. It works all the time. Okay, you guys hanging on so far? Let's see if we remember how to do this.
Yeah.
Average value. What is the formula for average value? And half of calculus is really just memorizing formulas. Okay, so average value. 1 over b minus a times the integral of what? Well, I want the average value of f of x, so I would put f of x here. Okay, guys, remember, if they ask you for the average value of f prime, then you would put f prime here. Does that make sense? If they ask you for the average value of g, you would put g here. If they ask you the average value of your friend's dog, you would put your friend's dog here. Okay, whatever they ask you the average value for, that's what you would put right here. All right, so let's go ahead and plug it in. What's my a and what's my b? 5 minus 1. Okay, I forgot my limits here. This would also go from a to b. So this will go from 1 to 5 of 5x4 minus 4x cubed. This is the dx problem. All right. Let's go ahead and try to integrate this by hand. Okay, I'm going to add 1, divide by 5, so that's x to the 5th. Add 1, divide by 4, so that's x to the 4th from 1 to 5. And when I'm done, I'm going to multiply everything by 1/4. This is my 1/4. All right, first I'm going to plug in the 5. Then I'm going to plug in the 1. Then I'm going to slap a minus sign in the middle. Okay? And of course, when I'm done, I'm going to multiply by 1/4. Okay? This is 0. This is 5 to the 5th minus 5 to the 4th, which I'm not really good at this, but I can actually take out a 5 to the 4th, right? If I factor out, don't they both have a 5 to the 4th? Then I can just say, well, that's just 5 to the 4th times 5 minus 1. And then when I'm done, I need to multiply this by 1/4. But 5 minus 1 really is 4, right? So these will cancel out. And so my answer is 5 to the 4th, whatever that is. 25 times 25. 625. Okay, you guys good with that? All right, can you do that on your own? What does this average value formula get confused with? Average rate of change. What if I had asked you for average rate of change? What formula would that have been? F of B minus F of A over B minus A. When you guys learned slope in Algebra 1 and Algebra 2, did they talk about average rate of change being the slope? Did you guys hear that terminology? Yes. Okay. So I'm hoping that you did. I hope you heard it a lot, because that way you don't get confused between average rate of change and average value. Because average value is like a calculus thing. Average rate of change, you should have known when you came into this room before I confused you. Okay. And you got them confused. Okay. But average rate of change is what you knew slope before you even learned calculus. Okay. All right. And if we did this, this would be f of 5 minus f of 1 over 5 minus 1. Right. And then you would just plug in. Okay, go ahead and pass up your warm-ups, guys. Let's talk about your future. Okay, so I've had a lot of questions about what we're going to be doing for the rest of the year. Okay, and I guess you're just asking because it'll motivate you, so here it is. Okay, in the third grading period, right before spring break, we only have one more major test, all right, and that's our parametrics, vectors, and polar, okay, and we'll finish up vector tomorrow, and then next week we'll start on polars, okay. In the fourth grading period, so this is after spring break, we have two new things that we're going to learn, series of convergence and divergence, okay, and Taylor and Maclaurin series, all right. I really like these units, but not everyone does, so we'll see if you do. And then after that, we're done. We're done with all content, okay? And then you just have a few more tests, okay? One is the big formula quiz. You have all the answers already, okay? I already gave you the test and the answers, okay, in pink sheet form, okay? All you have to do is memorize the right side. I will give you the left side. You just memorize the right side. So good luck, okay? That's your big formula quiz. That would be a major grade. And then we'll do a practice AP exam. We'll do two of them, okay, in class. We'll do one with a calculator and one with a non-calculator. And then whichever one is higher, I'll take that grade. Okay, so we'll do it over a period of 2 days. Your brain will be fried, okay, after we do that. Because you know how your brain like hurts after you take a long test? But we'll split it up because the test is like 3 hours long. And you only have a class period to do it. But then I'll curve these like the AP exam curves test. You guys know there's a big curve, right? So I think you have to make like a 65 or something to make an A, okay? So I'll curve those according to whatever that curve is, and we'll pick the highest one, okay? And then you have your TEKS exam after your AP exam. So your AP exam will happen right here after number 5. And then we come back from your AP exam because you're all studied up, okay? We'll just give you your TEKS exam, and I'll try to give it to you pretty soon. You probably, I don't know if you'll care or not. Yeah, it's probably good just give it to you soon because you're already studied up for your AP exam. Does that make sense? And our exam is on Cinco de Mayo, okay, so remember your sombreros, okay? And you're gonna take it, I think it's like a Tuesday, maybe Monday or Tuesday, and then I'd like to give you your TEKS exam as soon as possible after that because otherwise you're studying for other AP exams and everything's gonna get all mushed up, okay? So we'll try to take it as soon as possible after that. All right, so 5 major grades in the next unit. All right. What homework questions did you guys have last night? Did you have any homework questions? You're good? Okay, someone told me, and I don't know if it's true because I haven't checked, but under number 9 of your homework tonight, because all the answers are on the back, instead of 3/4, it should be -1/4. But I haven't checked on that, so I'm not sure if that's exactly true. But just FYI, if you're having trouble, someone else is having trouble too. Okay, I'll post that if there's a change. Okay. All right. Let's look at what we learned yesterday. Okay, you guys all did your homework? Okay, let's pull it out. Let's do a little bit of review. Okay. What we talked about yesterday is you have this thing called parametric equations. Okay, and we've always had equations with x's and y's, but now we've thrown in another variable called t, and that's kind of like just a third dimension. All right. But just like we always did before, we could always graph the curve on an x and y plane. The only difference is now, when we graph the curve, that it has direction. Okay, so now that we have a t, we have direction. But there was nothing different about the way it could be graphed. All right, and then we said, hey, if we have parametrics and we have a curve, we could also find the derivative of that curve, the dy dx of that curve. Okay, and it meant just like it meant before. What it meant was if I pick a point, and I get closer and closer and closer and closer to that point. If I look at that point, the slope of that tangent line, okay, so there's a little tangent line there, the slope of that tangent line would be my derivative, and I could calculate that. But with parametrics, I had to use a different formula, and that was dy dt over dx dt, because now I have a t, okay, in my given, okay. So right here, I memorized this formula, and I said, you know what, though? You could actually also get the second derivative, okay? But the second derivative was a little tricky because when I found this answer was in t form. So when I took the derivative of this, I needed a dt dx. Do you remember that? So this ended up being, you take the derivative of your dy dx, so it was dt of the dy dx. Okay, because remember, this is in t form. And then I had to divide by something. Do you remember what I had to divide by? Dx dt, okay? And so this became the second formula you had to memorize. You had to memorize that one, and then this one in green, okay? And then we said, okay, we've got the first derivative and the second derivative. What else did you guys learn yesterday? We said we can find the arc length of things with parametrics. We already knew one of our arc length formulas from before, okay? One arc length formula was S is equal to the integral of 1 plus dy dx squared. And that was really useful if you didn't have t's. Actually, still very useful if you don't have t's. Okay, so that would be dx, and this would be from x1 to x2. But we said if we have t's, while we could use this formula, okay, it's a little bit easier to use ones that have t1 and t2. Okay, and these two formulas are really exactly the same, all right? They're just, one's more useful in one situation, another is more useful in another, okay? And do you remember what was inside the square root now? Dx dt squared plus dy dt squared. And instead of a dx now, we have a dt. That's super important because what that means is our limits now are not x's, they are actually t's that you would put here. And then we said, hey, lo, that looks familiar, okay? And we said that looks a lot like what other formula that we had talked about before? The total distance formula, okay? And it turned out that this formula was exactly the same, okay, as the total distance formula that we learned before. And I just want to stress, when you plug in your v here, though, when you plug in your v, that this v is actually a v of t, okay? It's actually an expression here. Don't just put in a number. It's got to be some sort of expression, a function with respect to t. Okay, now I'm going to ask you something. I didn't talk about this word yesterday, but there's an S word. It's not 4 letters, okay? There's an S word, okay? That is also what you could call this and this. What is that S word? What is this really representing? It's velocity with an absolute value. That is really speed, okay? So this in here was really just speed. So if they ask you for speed, which we didn't, I don't think your homework last night asked you for it, but if they ask you for speed tonight, then what you would do is you would just get this part right here, this part that I'm kind of highlighting in red, okay? And that's your speed. Okay, so that's a new formula you have to know. This part right here is your speed. What do students get confused by? I ask you for speed and you tell me arc length, or you tell me total distance. Does that make sense? Or I ask you for total distance and you tell me speed. And the reason is because one is inside the other. Does that make sense? But make sure you understand, speed is just the square root part. Because remember, speed always has to be what? Speed has to be positive, right? And if you square root anything, that makes it positive. If you do an absolute value, that makes it positive, right? So speed always has to be positive. That's why it's just this inside part. Okay, let's go back then to pull your notes out from yesterday. And we didn't finish number 3 in your notes from yesterday. Okay, so leave your homework out. Okay, I want to check that. But we're looking at number 3 on your notes from yesterday. And we're going to talk about horizontal and vertical tangent lines. Okay, so remember when we talked about parametric equations, we said if you drew that curve, and now guys, we're not talking about functions anymore, okay? When we actually graph this thing, it can fold up on itself. It doesn't pass the vertical line test necessarily anymore, okay? If I wanted to know all the points where you had a horizontal tangent line, okay? Make sure you guys understand not to be confused with the horizontal asymptote, okay? This is a horizontal tangent line. What that means is if I get closer and closer and closer, so close to this curve that the slope of the tangent line looks like a horizontal line, okay, that would be where the horizontal tangent line is. So if you were to guess where the horizontal tangent lines were on this random curve, where would you say it is? Maybe at the bottom, so maybe like right there, okay, and where else? Maybe like right there, okay? And how did you know that? Because you're so far away, I don't even know how you knew that, okay? But when I'm up here, I can see that when you get so close, right there, okay, that slope of the tangent line is actually a horizontal tangent line, okay? So that's how I knew. All right, so if there is a horizontal tangent line at these two spots, what is the derivative there? 0. So do you agree the dy dx would be 0 here, and the dy dx would be 0 here? So if I wanted to find out where that point was, I would just set dy dx equal to 0. Okay, what about vertical tangent lines? If I were to identify where the vertical tangent lines were on this curve, where would you say there were? Maybe here, maybe where else? Maybe over there. Good. Perfect. Right answer. Okay. So guys, if this is a vertical tangent line, what do you think the derivative is? 1 over 0. Very good. And you don't have to say 1 over 0. You could say 5 over 0, 212 over 0. Okay. But you're going to get the same answer. And over here, the derivative will be 1 over 0. Okay. Knowing what we know then, okay, if we wanted to find a horizontal tangent line, okay, what that would mean is that dy dx is equal to 0. That's what you told me. But since we have parametrics, what that really means is dy dt over dx dt is equal to 0. And really not just 0, 0 over 1, right? So if I cross multiply, what does this really mean? That dy dt is equal to 0. And that's what you need to know. You need to know that anytime you want to find a horizontal tangent line for parametrics, you just need to know that dy dt is equal to 0. Do I memorize this? Actually, I don't. Actually, I just kind of go through this in my head every time. Okay? And I know that the numerator's got to be 0 if I have a horizontal tangent line. Well, what does that mean about a vertical tangent line, do you think? Very good. So on the vertical tangent line, we said that this is going to be equal to 1 over 0. So that means dy dt over dx dt, this is for parametrics, is equal to 1 over 0. And if I cross multiply here, okay, then what I would get is dx dt is equal to 0. All right. Okay, so what I've learned so far is if I'm trying to find vertical tangent lines, I will set dx dt is equal to 0. And if I want to find horizontal tangent lines, I'll set dy dt equal to 0. So let's find the horizontal and vertical tangent lines here. All right. When x is equal to t, oops, let's do the y. When y is equal to t squared minus 3t plus 5, what's dy dt going to be? 2t minus 3, okay, is equal to 0. Therefore, t is equal to 3 over 2, right? Okay, now I got to stop here because I got to figure out, did I answer the question? The question said, find the point where there's a horizontal and vertical tangent line. You guys good with that? Remember when we talked about this yesterday? If I drew a curve, I remember we plotted it, we said, okay, t equals -2 there. T equals 0 here. T equals 3/2 here. T equals 5 here. Okay? So what I figured out is I figured out that this point right here, that's where t is 3/2. Okay? But that's actually not the point, right? They said to find the point. What format does a point look like? X, Y. Okay, so what I need to find is X and Y when time is 3/2. Can I find that? I certainly can, because I have got a formula for X and Y. So let me go ahead and put that in here. I've got X is equal to t squared plus t, but here I want to plug in 3/2, so that's going to be 3/2 squared plus 3/2. And so that's going to be 9/4 plus 3/2. And that's going to be 9 plus 6. Did you guys get 15 over 4? Okay, that's my X value. All right, how do you find your Y value? Yeah, you just still plug it in. So right here, you've got Y here. So Y is equal to, this is, I think it's 3/2, right? So 3/2 squared minus 3 times 3/2 plus 5. Okay, what's 3/2 squared? 9/4. 3 times 3/2, 9/2 plus 5. Sometimes when I do fractions, I feel like you guys are just waiting for the answer. Okay, 9 minus 18 plus 20. 11 over 4. Can someone second me on that? Good. Okay, so I've got 15/4, 11/4, and that's my answer for horizontal tangent line. You guys good so far? Let's do the same thing for a vertical tangent line. Okay, so let's go back. We're going to do a vertical tangent line, and we said that the vertical tangent line, okay, is going to be when the slope is equal to 1 over 0. okay? That means that the denominator here is 0, and this denominator, remember, is dx dt. This numerator is dy dt. Okay, so what I'm going to do is I'm going to set dx dt. Actually, this isn't really dy dt. That's actually not correct, because you know what I'm saying? Because this could be 212 or whatever number. Really, the important thing is that the denominator is dx dt. Okay, so this right here is going to be 0. So what I have is 2t plus 1 is equal to 0. Okay, if 2t plus 1 is equal to 0, what's t? Did you get negative 1/2? All right. Okay, did I answer the question? No, it says find the point where you have a vertical tangent line. Okay, so that means I need an x and a y. All right, so I know my t, so my t is going to be 1/4 plus 1, no, that's not right. 1/4 minus 1/2, 1/4 minus 1/2, which is negative 1/4. Okay, my y, do you guys see I'm just plugging in the negative 1/2? My y is going to be 1/4, negative 3 times 1/2 is negative 3/2, no, positive 3/2, plus 5. Okay, so get a common denominator here of 4. I'll have 1 plus 6 plus 20, which is, can someone give me a check? I've got 27 over 4. Yes. And so this is going to be, there's a y and there's an x. So this is going to be negative 1/4, comma, 27 over 4. And there's my position. Okay, any questions about that? Okay, and so just an FYI, position is, I do it with parentheses, and AP is okay with it with parentheses, but you know it's really a vector, right? So technically, when you look in most textbooks, they'll do something to signify that it's a vector. Sometimes it's these brackets. Have you guys ever seen that? Okay, so sometimes it's a bracket. Sometimes they'll do like an I and J. So like they'll say this in the I direction and this in the J direction. Have you guys seen that? Okay, so whatever floats your boat, AP will accept all of those forms. Okay, it's a vector. I just like the parentheses because it's easy. Okay, all right, let's go look at, oh, okay, so now you're ready for 8 through 10. Okay, if we have some time at the end, we'll just start our homework together and possibly just do number 10 together. Okay, but let's start with vectors. So we're done with mostly parametrics. Look on your notes for today. Okay, what we're going to start out with is, it's going to seem really easy, all right? But as you apply it, there's some problems that some thinking is going to be needed. This homework won't be as hard as tomorrow night's homework, but still, there's things that you need to understand, connections, how things work, all right? So the first thing you need to know is anytime you see an x prime, that's really velocity, right? That's your x component of your velocity, which is also called dx dt. So this is dx dt, the x component of your velocity, okay, the horizontal component. And then there's also a y prime, okay, y prime is also velocity, but is the y component of your velocity, okay? So when we did motion earlier this year, we never traveled like on a diagonal line. We always traveled only horizontally or only up and down, okay? So that's calculus AB. So in calculus BC, now we can go diagonal, and that's a relief, okay, because we can get places faster, all right? We're going to go in curves and diagonals here, because now we're on a plane. We're no longer on a line. And what we know actually is, since these are, the vectors, the component vectors for velocity, we can actually do a little calculation, right? And we can figure out the magnitude of velocity. Okay, so the magnitude of velocity is actually equal to I'll do dx first, dx dt quantity squared plus dy dt quantity squared square root. Okay. Now students get confused between this and what? What do you think? This and total distance. Okay. So if I ask you for distance, please don't give me this. This is actually velocity. If I asked you for total distance, what would you do? You would integrate this. Okay. Because remember, total distance is actually the integral of your velocity. Okay. All right. So make sure you don't get those confused. And then what we're going to do is go on here. Okay. If I ask you on a formula quiz to give me the position vector, okay, what you want to do is just say x, y. Okay. And actually, if I ask you on an AP test or a test to give me a position, all I'm asking you for is x, y. So I would encourage you guys to just write x, y, because what it does is it gives you a goal to shoot for. Otherwise, when you're doing your problem, like in the process of all of it, you're like, what was I trying to find in the first place? I don't even remember, okay? So if you write x, y, you have like something to shoot for. And if I ask you for a velocity vector, okay, just write down right away x prime, y prime, because that's what you're shooting for, okay? And if I ask you for acceleration vector, then you would put down x double prime, y double prime, okay? And it's so easy to do this, okay? Why not do it so that when you're solving a problem and things get confusing, you know what you're shooting for, okay? We've already talked about dy dx and then the second derivative. I think we did a review on that already, right? So I think we're good on that, all right? And I think I've talked about this already. Okay, so let's go to example 1. All right, so example 1, you've got an xy plane, okay? So we're no longer in a line, we're on a plane now. You're given the position, x, y. That makes a lot of sense because position has an x and a y. And it says, give me the velocity vector. Okay, so right away on my paper, I'll write x prime, y prime, because they want the velocity vector. That's what I'm shooting for, okay? So if I have x, can I get x prime? Sure, let's do it. If I have x, x prime is going to be the derivative of x, which is 3t squared plus 8t. Okay. All right, I actually don't want x prime. I actually want x prime at 1. So you guys good plugging in the 1 there? If I plug in time as 1, I'll get 3 plus 8, so I get 11. Okay, let's do y prime. Y prime is going to be the derivative of your y, which is 4t cubed minus 3t squared. Okay, I actually really don't want it in the form of t. I want t to be 1. So this will be 4 minus 3, which is 1. Okay, guys, they want the vector, so the vector is going to be 11, comma 1. Is everybody good so far? All right, what if I wanted acceleration vector when time is 2? Let me just write down. Acceleration means x double prime, comma, y double prime. Right, so if I have x prime, can you give me x double prime? Sure, xt plus 8. But 6t plus 8. But if I want this as a number. If I want it when time is 2, what you have to do is plug in t equals 2, and what do you get? 20. All right, let's do your y double prime. Your y double prime is going to be 12t squared minus 6t. Okay, but if I want acceleration at time 2, that would be 12 times 4 minus 12, which I believe is 36. Okay, so your acceleration, be careful. They didn't just ask you for numbers. They said, what is the vector? So your vector is 20, comma 36. All right, easy? Okay, let's move on then. Number 2. So number 2, we're given x and y again. We're given time is greater than 0, which is nice. I like that. And then they're asking you for the magnitude of the velocity. The magnitude of the velocity. Guys, most of this is just formulas. What is the magnitude of the velocity formula? Square root, or is it integral? Square root, okay. dx dt squared plus dy dt squared, okay? And then do I put a dt and integrate this? No, because that would make it what? What happens if I integrate this? It would make it total distance, okay? So there's your velocity formula, or your speed formula, really. Okay, I want time to be 1. And so do I know dx dt? Yeah, it's not too hard to figure out. That's 2t plus 3. I'm going to square that. What's dy dt? 3t squared minus 6t. Okay, square root that. Okay, am I done yet? One more thing I need to do. You have to plug in your time. Okay, so your time is 1. So I'm going to plug in time is 1 here. That's going to be 25. 5 squared, which would be 25. Plug in 1 here. Here, let me just put 5 squared. This is 5 squared. Plug in 1 here. That's going to be negative 3, I believe. Negative 3 squared. Okay, that's going to give me 25 plus 9, which is the square root of 34. Can you simplify that, Amy? The only thing, that's 2 times 17. Yeah, I don't think it'll simplify. Okay. All right. Any questions about that? The great thing about AP though is you actually don't have to simplify, but you do have to know, if we're a multiple choice, you wouldn't even know how to simplify if it were in the choices. Okay. Let's look at number 3. Did we answer the question? Did we? Yeah. Okay. Let's go to number 3. All right. Number 3 says. Students have a lot of trouble with this, but I think it's just because you're not drawing the picture, okay? A particle moves in a plane. You have x and y, okay? That's you're given, x and y, which is nice, parametric equations. T moves between 0 and 2 pi. The path of the particle intersects the x-axis twice. Write an expression that represents the distance traveled between the two x-intercepts. So distance traveled is what I want, okay, between two x-intercepts. All right, let's just talk about formulas. It's really just a formula problem. What is the distance traveled formula? Total distance formula. So let's do it. The total distance formula is equal to, does it have an integral or is it a square root? Integral. It's going to be the integral of the square root, okay, of dx dt squared plus dy dt squared. Is this a dx problem or a dt problem? dt. Okay, this is super important because if you memorize this right, it's a dt problem. If this is a t, what does that mean about these limits? They must be times. Okay. On the other equation we use, they're actually x values. Okay. Before we learned parametrics. All right, but now we've got a t. These are times. And so what students do wrong here is if you look at everything, do you know your dx and your dx dt and your dy dt's? It's pretty easy. We can figure that out. Okay. What students do wrong here is right in this T1 and T2, they put in 0 and 2 pi. Okay? That's actually not what they're asking. Does that make sense? Okay, let's just talk about y. The path that intersects the x-axis twice. So let's think about what we're doing. We've got some path. It intersects the x-axis twice. So let me draw it. It intersects the x-axis twice. Okay? And we talked about this yesterday. As we plot like all these points, okay, as we plot all these points, each point represents some time. So this might be time at -2. This might be time at 0, okay. This might be some other time, I don't know. This might be time at, let's call it time at 3. Try and get some smaller numbers here. Time at 1. This might be time at 2. This might be some time. This might be time at 2 pi, okay? If I put 0 and 2 pi here, would I actually get the length of the curve? Does that make sense? Because I want the time at 2 particular instances. What 2 particular instances do I want? When it touches the x-axis. How do I find the times when this thing touches the x-axis? Is that y equal to 0? So my x equal to 0? Is x equal to 0 here and x equal to 0 here? No. What do I say equal to 0? So my y equal to 0. You guys good with that? If you set your y equal to 0, okay, you'll find the x-intercepts, okay? So I come up here, and I set my y equal to 0. And you see, if you do that, you'll get the time when you have your x-intercepts, when your y is 0. So what I'll have here is 2 sine t is equal to 1. Therefore, sine t, divide both sides by 2, is equal to 1/2. Okay, guys, when the t is sitting next to the trig expression, then the t is an angle. So let me think about my unit circle. At what angle is my sine value 1/2? At what angles does that occur at? Pi over 6, and where else? 5 pi over 6. I think we need a unit circle quiz. Okay. Maybe it'll boost your formula quiz grade. Okay. Except for the tangent part. All right. So I've got my 2 times. What do I do with these times? Yeah, you plug it in right here. So this is going to be pi over 6. And this right here is going to be 5 pi over 6. And let me just rewrite this so you can see what this should look like. They said we don't have to evaluate it, so that's a relief. All I have to do is write the total distance formula, which is from pi over 6 to 5 pi over 6 the square root of my dx here is the derivative of my x. Okay, what's the derivative of negative 4 cosine t? Positive 4 sine t, right? 4 sine t, but I gotta do a quantity squared. Okay, what's the derivative? Derivative of 1 is 0. What's the derivative of minus 2 sine t? Minus 2 cosine t. All right, so this is going to be a minus 2 cosine t. Don't forget to square it. Don't forget your dt, and I'm done. Okay. Technically, if I got my negative signs here wrong, would it matter? No, it wouldn't matter. Technically, it wouldn't matter. But, I mean, the derivative does have a negative, but if you didn't put it, you'd still get the same answer. All right, let's look at number 4. Number 4, you have a particle in a plane. Nice. You got x and y again. T is greater than 0. I like that. For what value of t is a particle at rest? Okay, I need to think about this. Guys, the particle is not necessarily at rest when x equals 0, y equals 0. That just means you're at the origin. Does that make sense? And you could be running through the origin. Does that make sense? So that doesn't mean you're at rest. What has to be 0 for you to be at rest? Yeah, the velocity. So actually x prime must be equal to 0. And or y prime is equal to 0. Now let me think about this. X prime is really the x component of the velocity vector. You agree with that? And dy dt, or y prime, is really the y component of the velocity vector. Okay? If I want my velocity to be 0, okay, what needs to be 0 here? Both of them. You guys good with that? Because if just this one were 0, I would still have a dy dt. And if this one were 0, I would still have a dx dt. Okay? So what I want is and. Okay? I want both of these to be 0. Okay? So what we're going to do is we're going to try to find the time when both of these are 0, because that's when the particle is really at rest. All right, so let's figure out my x prime. X prime here is going to be 6t squared minus 30t plus 36. Okay? If I want this to be at rest, the velocity has to be what? 0. Okay? So I'm going to solve for the time here. Pull out your 6. Pull out your 6. And I'm going to solve here. And so all I'm doing is factoring. I'll get 6 times t minus 3 times t minus 2. And be very careful here, guys. If I get something times something times something equals 0, what does that mean about one of these somethings? It's 0. And I can't tell you how many students still tell me that t is equal to 6. Okay? Nowhere here is t equal to 6, right, guys? What this is telling me that what's equal to 6? 0 is equal to 6, which is nonsense. So I just ignore that. Or t is equal to 3, or t is equal to 2. All right, so that's what I get on the x side. Let's check the y side. Okay, so remember it has to be 0 for both sides. So on the y side, y prime is 3t squared minus 6t, right? And that must be 0 for us to have rest. All right, let's go ahead and pull out a 3t. You might have just wanted to pull out a t, and that's fine too. Okay, I see a 3t. All right, if something times something equals 0, that means one of these things is 0. That means either 3t is 0 or t is 2. If 3t is 0, then t is really 0. Okay, what's your answer here, guys? It's 2, because it has to be 0 on both sides, and the only one that works out is 2. And if we had nothing that matched, then the answer would be there's no answer. All right, but something matches here. All right, and let's look at example 5. Okay, example 5 is where students have the most trouble. Okay, and I think the reason is because they don't know that they need to break up the x and y components to do this problem. Okay, so you've got a particle in the xy plane. You've got a velocity vector. Oh boy, velocity vector. What is that? X prime, y prime. Okay. They give me a position vector. Okay, what's a position vector represented by? X, Y. And then they ask for a position vector. Wait, if they give me a position vector, how could they ask me for a position vector? That's so weird. Yeah, You would solve for c. Hold on, this is x of 0, though, just to make sense of this. And this is really y at 0. You guys good with that? And what they're really asking me for is x at 1 and y at 1. Okay, you guys good that this is what I'm trying to find? Okay, I don't mind the c way, but I'm going to show you a different way, just because the c way doesn't always work. Okay, because if you can't integrate by hand, then it won't work. It'll work here, okay, but it won't work always. Okay, so I'm going to do it with the first fundamental theorem of calculus. But I just want to let you know, if you want to do the c way, go for it. Okay, it'll work. Not all the time, but it'll work for this one. All right, so what I'm going to do is I'm going to say, you know what? I've got x prime, and I want to find x. What equation in calculus has x prime in it and x in it? Like it ties derivatives and antiderivatives together. What formula is that? It's the first fundamental theorem of calculus. You guys good with that? What is the first fundamental theorem of calculus? It is the integral of x prime dt, okay, is equal to the antiderivative of this x prime, which is x, right? Of some number minus x of some number, right? First fundamental theorem of calculus. We actually know, well, this is a dt. It's helpful because I put t here. If this is a t, what are my limits supposed to be? T. So what two t values do I have in this problem? 0 and 1. Okay, well, if I put 0 and 1 here, be careful, make sure you do that right. The 1 should go here, and the 0 should go here. So using the first fundamental theorem of calculus, I can just plug into this equation and get my answer. Okay, how would I do that? Well, do I know what x prime is? Okay, it's right there. 3t squared minus 4t dt. Do I know what x1 is? No, but I'm trying to find it, so it's good to have it in my equation. Do I know what x0 is? Yes, it's 7, so this is minus 7. Okay, and you guys see I can solve for everything except for the x1, because I can get a number for everything. So I can solve for x1. So let's do this by hand. I'm going to add 1, divide by 3, so it's going to be t cubed, minus, I'm going to add 1, divide by 2, so it's going to be 2t squared from 0 to 1 is equal to x at 1 minus 7. First I plug in the 1, then I plug in the 0, then I slap a minus sign in between. And so what I get is negative 1 here, right? So negative 1 is equal to x at 1 minus 7. So what do you guys get for x of 1? 6. Okay, that's nice. I've already got half of my answer. This answer up here is 6. I need to find my y1, okay? And so all I do is the same thing for the y side. So you guys can do it. You guys work on your own, and I'll work on the board here. It's really the exact same formula. All the x's get changed to y's. Be careful when you plug in y0, though. Do you guys see why you need to be careful? You're subtracting a negative 4. So that's going to be an addition on this right side. Okay, so did you get 7 is equal to y1 plus 4? Did you get 3? Okay, so your answer is going to be 6, 3. How fun was that?